Suffering! Yeah, baby! His commencing suffering has been taking place since the last 21 years, bro. And that was kinda fucked up sentence because I wanted to say since timestamp and then I wanted to say for the last 20 years. And then since time span happened. Well, anyway, with that, let's get to the fun part, eh? Hey, Jurassic Jigsaw. Like we read that last time. But my brain was mush, so I have no idea what we actually read. The high-speed train leaves the forest and quickly carries you south. You can even see a desert in the distance. Since you have some spare time, you might as well see if there was anything interesting in the image the Mythical Information Bureau satellite captured. After decoding the satellite messages, you discover that the data actually contains many small images created by the satellite's camera array. The camera array consists of many cameras, which kinda is implied by the name. Rather than produce a single square image, they produce many smaller square image tiles that need to be reassembled back into a single image. Each camera in the camera array returns a single monochrome image tile, which with a random unique reassemble. Yes. The tiles, your puzzle input, arrived in a random order. Worst yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped as well. Oh my. To random orientation. Your first task is to reassemble the original image by orienting the tiles so they fit together. To show how the tiles should be reassembled, each tile's image data includes a border that should line up exactly with its adjacent tiles. All tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. For example, suppose you have the following 9 tiles. Duh. By rotating, flipping, and rearranging them, you can find a square arrangement that causes all adjacent borders to line up. For example, the IDs of the above tiles are... To check that you have assembled the image correctly, multiply the IDs of the 4 corner tiles together. If you do this with the assembled tiles from the example above, you get this number. Assemble the tiles into an image. What do you get if you multiply together the corners? How many tiles do we get? This is a bit quiet today, isn't it? Mm-hmm. Fun is being had. And of course, I said it's kinda quiet, and now Mr. Cheeks, that pie. Now Mr. Die obviously has to slam into the keys to be super loud again. So I can fix it. Now that I fixed it, it's the quiet piano again. Well, whatever. So, I mean, honestly, considering that if we implement this properly, the sample size shouldn't matter, because, well, the logic is the same, right? So this is obviously just here, so we can't do it by hand, because that would elsewise be the easiest way to do it, whereas... The only issue is, how do we go and solve this logically? Essentially, couldn't I just assemble all of them together at once? And then, because they're all, what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all 10 tiles large, 10 by 10. So I could then just, well, in a way, just swap them out and rotate them, essentially brute force it. But I think that this will be way too long. Like, that won't finish ever, right? So we probably have to do something a bit more applicable. It's not that much, so I want to brute force it. So then the probably you say, because then the hard part is probably getting it to do the brute forcing for me. Implementing that might be the difficult thing then. So first off, let's parse this in. I'd separate this probably in a dictionary, so we have the tile name as an ID. And then I suppose a numpy array as, well, the array. And that's in there. Well, brute forcing, you just let me second. You essentially you just put them all like this in the order you read them in, and then you just swap them around over and over, as in trying every possible combination. Yeah, that's kind of what I figured brute forcing is, but that's also why I said it's gonna be way too intense. Yeah, that won't finish. I said that. Yeah. Which was why I was so surprised when you told me, no, it's easy, just 144. Yeah, obviously, bro. Yeah, it's not. It's even more. Because every single thing can be rotated in 4 different ways, and it can be flipped as well. Is it really though? I'm not so sure. because you could have everything exactly the same, but then you can have each one individually in a different rotation, or two in a different rotation, and so on. Oh god, that is... Is that loud? I'm not sure. Anyway, so first off is the parsing, which would be... not this. Let's just call it tiles, which is a dictionary. It's about 20% louder than me. Well, my audio meter here would disagree, but let's see. The problem is I don't feel like this actually does much. I mean, this is essentially the lowest I can go. Now it's 20% less loud than me. Well, good enough for me. That would be import numpy as mp. Did I do it correct this time? I did. Poggers. Oh boy. I don't even want to... like, I don't need to do this here. Actually, I can just call this a temp and initialize it in here. Then we do it like this. Well, obviously in... so if it's an empty bar, which marks the end of every tile, then temp is again an empty array. And well, we don't really need to reset tile ID. And then you can continue. So, if tile inline name equals line -4. Is that the last 4 from the back? Was that how that went? Since this is always 4 digits. And then ignore the very last one. So, like this, right? Because we don't want the column. So this is -1, this is -5, and then that should give us these, I think. So, and we can also continue. Indeed! Actually, let me just Let's do this with an elif and remove the continuous. My parsing is so Java. Dude. You can't lay off your roots, am I right? So now in every other case, for char in line. Oh, and I suppose you should be mp.zeros at the very start. But we also need dimensions, so you have to be 10 by 10 in a tuple, and I want you as int. Okay. Oh, I forgot about this. Alright. So for each char in line, if it is... I mean, this doesn't even matter, right? But let's just do if C is the hashtag. No, I suppose we also need a count here. I mean, unless... So you always start 12 lines apart, so I can just modulo this. Since, like, line 1, line 13, so I can, yeah, sure. Then we can just enumerate this as well. Like, is that smart? I have no idea, but it seems like a viable thing to do. You would have to be J then. Now for temp in I modulo 12 minus 1. Is it minus 1 or minus 2? Let's see. Since we start at 0, minus 1 would be... okay. Then this is 1, minus 1 gives us 0, so it starts where it should. And here we can do J. That should do it. Now we just need to say, in that case, it's 1. And I suppose for good measure, let's just print temp whenever this happens. And what we also would want to do is tals equals temp.copy. Oh, it's tal ID. Well. They keep coming, don't they? They just keep coming. So that means it never gets to this, right? You would get Read split on this. Okay. Well, my thing is not working anyways, so. So then instead of this we would do for each. So we won't need that anymore. Yeah, so that is just something that happens at the end anyways. At the very end of each tile. And then we just, instead of this, we do tile ID is just well, first off, I mean we can do that, so that's really cool. We can do tile is tile dot split lines. Now we can do for first tile you can get tile ID and oh. Oof, he says. Yeah, I can probably do that here already, right? But I don't know how. My naming is unfortunate, oh well. That kind of sucks then. Well, yeah, kinda, but it is. It is all the text that describes a tile, right? So here we can go and enumerate, starting from 1 onwards, and then for each of the lines we can do for J. Fuck. Dude, it's just not fair. It's not fair, dude. It's not fair, man. A Boolean array. mean, a Boolean array does the same thing anyways. For an int, I would just check if it's 1 or 0. Yeah. I'm just thinking what to call this. Because, lines would rather be the whole thing, right? I mean, let's first rename this to just data, because that's what it is. Or input, I suppose. And let's just do lines here. Huh. Oh, unexpected indentation, yeah. Obviously. What else? So we don't need temp here. We arguably don't need tiles ID either, because now here we can just do this in a fancy one-liner. Then we don't need this either. Question: is there a way to do this here already? Like, is there a way to do it inline? Because that would be hella cool. So I could say map. Then I put the function here. So that would be kind of strange. Okay. Let me try it. So why does it want a bracket? What am I doing? I'm trying to do a map, but I have no idea what I'm doing. I mean, this obviously won't work. Yep. Is that how it's done? Oh, apparently it is. It isn't. Well, sucks to be me then. This is a string though. Hey. Wait, but function, would that mean I can just do that? No, I cannot. It already gets that it's a string, so seems correct. Maybe? Looks good. It's interesting that it is formatted so weirdly though. Oh, that's what I was kind of searching for, because in Java you can do a method reference and it automatically gets it. Hey. Okay. it still worked though. Wait, no, I didn't save. Well, Yeehaw! Wait, did it also work before, or did I not save? And that's why it worked. Okay, yeah, I didn't save. Good. Alright. So you said it would be kinda strange. Do you want to tell me why? Because I'm not sure. Is it just for readability? Better to do it here? Just not used to it, okay. You still learn, bro, you're already the big G in this. Also, this is just gonna, oh yeah, this is just gonna auto format. Okay, so we successfully can I immediately do that here? Because I know for a list you showed me one of these where you can just transform this into here, right? For a dictionary, how exactly would I do that? Because it looks kind of like something that you showed me before, but I think we only did it for lists. Mm. Oh, okay. Yeah, I was just about to wander. Okay, this is really cool though. Okay, this is not cool. Okay, so we haven't done much so far, but at least we did a fancy one-liner. Pog. Stream's done. We peaked. It's not gonna get better. So actually, what exactly do we even have to do now? Because I gotta be honest, I am not even close to a way to do this without waiting 10 years for it to finish. So is it actually that I take all the borders, assign them a direction, and then just match the borders because I don't need the rest here, right? Because the one thing I was kind of thinking is, like, get this, get this, get this. You need it later. Oh yeah. You made it into numbers. What? How did you? Huh? I have no idea what you mean by you made it into numbers. You're also really confused. Yep, I can definitely imagine. You don't want to know. Oops. So I suppose first we could write a function that extracts us cut borders so that we give a tile. And this bad boy, well, tile is a matrix, which is 10 by 10. So Yo, is there a way for me to slice, well, a line from an array? Like if let's say, again, tile is a numpy array, dot slice 110, and then it gets me the first, well, should presumably do 0, 10. And then that gets me the first tile or something. Oh, cool. And I assume the same thing for... if I put the column on the other side, it's gonna be for columns, right? Just instead of this, obviously we're going to want to do this. The one thing I'm really interested in is if I can do this. I think this works in JavaScript, but I also gotta be honest and confess that I never really used it. Yeah. I figured as soon as it gave me the error thingy, but I wanted to write it out first. So, and now, if I do this, couldn't I just theoretically But wait. Oh, it always expects a key. Well, that's an issue because I don't know any. Well, I mean, we can just... We can just get one from this, right? But doing that is kind of a waste, isn't it? Because we could just be doing values. Oh. Dict values. Object is not subscribable. What? Huh? Is that what you meant by numpair arrays aren't hashables? But I didn't use them as the keys, right? Oh, because that doesn't give me the item itself. Oh. But that's kind of an issue then, though. How do I get the first one then? Heck, let's just do that then. I mean, this is just for testing anyway, so. Oh, you have to do it into a list first. Okay, okay. But what I initially wanted to test now is if I call top here now, it should instantly return me a very scuffed top. Wait. What? Because because why? Why aren't there any commas here? Why are is it arbitrary how many spaces there are? Well, arbitrary it isn't. It's always before a true that there's one space more. Oh, same size for all entries, okay. But still, why are the commas? The commas are gone because I'm now accessing the array itself, I suppose? They take space, I see. Yeah. But with ints I need to remember which one is which. Okay, so thing is, I am not so sure how to do the entire. Oh, you meant here. Okay, I see. I meant for this, not for this. Oh, so. So do I just do zeros then instead? Nope. That is not it. You showed me that somewhere. Just use 0, 1 works the same as false and true. Oh. so I just do that at the end. Oh, what? I see. And then obviously one more here, and error is 0-dimensional. Before ampere. Okay, well, Asia Pasia, man, Asia Pasia. So small, and if we remove this, then presumably this still looks awful, but it's a bit better than before. Okay, so now that there has been more stuff happening, but I still have the issue that I'm not quite sure what to do. So let's see. How would I go about this? I mean, technically, I could build up a net with all the borders, like just pick a random one to start, and then wait until I find one that fits on it, wait again, and just keep that going until I don't find any that fit anywhere. And if I'm done, then I could look at whether the thing I have is an actual 12 by 12 grid or if it's a different shape. Or couldn't I make a 12 by 12 array, assign that with the tile IDs, and just try filling that, while also specifying that everything has to well, fit properly. Or what I could also do is build a lookup table of everything that can fit to a different tile. Like compare all the tiles from tile 1 with all tiles of tile 2 and write down every tile they match, and then do the same again for tile 3 and 4 and 5 and 6 and 7. But wouldn't that alone already cost quite a bit of runtime? Well, probably not, because it also means I have less to compare the further in I get, so it evens out again. The thing is, once I have that lookup table, what exactly does it do for me? Oh yeah, perfect. Perfect music track for this, huh? I'm really not sure. What is the best way to solve this? I mean, I could potentially build all valid rows of 10, of a length of up to 10. And if I have that, then I could... Well, I could always say if you match anything, then you can try finding something that matches that on the other end. And once you have something, then, well, try to find a new row of 10, or find the row of 10 that you built that matches that one. Let's pump out the paint, broskies. Okay, but not this paint, let's get the good paint. Okay, so multiple ideas. Either we build a lookup table where for each tile 1 we list all matching tiles with tile X. Which can also be a different tile. And we do that for every single tile, and with the info we get from that we could presumably build up the image, right? So that is idea 1. Let me get the color. Alright. That is idea 1. So idea 2 would be to essentially build all potential rows of length 12. How many do we have here? God damn it. So get all of these, and then with that info build "12 rows that stacked on top match," right? Like that's the second option I could see being a thing. Yeah, that's kind of the thing. Well, I would know, since I'm I'm building a line for the first part, and in this example I think I started with this one, so this is 1, Whoops. Let's keep the colors consistent. So this is 1. And then this was 2, it matched here, this was 3, it matched here, this was 4, this was 5, this was 6, and then 7 didn't match, but it matched here. So we can build on both sides, that's fine. Then we have 8 here, 9 here, 10 here, 11 here, and 12 here, right? And with that we have 1 12 pack, but now obviously if we have something that matches on 12, then we would also need to build every other possible variation of this, right? Or also if 11 and 12 would be a cycle, then we would need to get every cycle. So we would load all of these into a set. And maybe try for each entry in the set to index shift it by 1 until it produces something that was already in the set. Or until it produces the same thing again, I suppose. And for this one, I mean, technically, if we, after this, don't find anything that matches the 3, then sure, we can drop another one on top, right? Then this would be 4. And at one point, then we hit number 12 here, and then we win. The only thing is that for that I need to Yeah, we need to check every single possible border there could be. For example, here, when searching for a match for this border, we keep this one fixed and search for a match in all other borders. And when we find something, then we need the other side of this one, and then we keep that one fixed and search for a match. The only thing again here is that if I have 2 potential matches, then obviously I'm going to need to split it, alright? Can't have 2 matches? Are there no 2 matches in this? Wait. So every tile can only be matched with one other tile. Oh! Wait, what? No, I mean, for example, you see this line. I could have this line again. Like, I have to have this line again, but I could also have it 2 times, right? And if I have a matching border twice, then I need to build only once, wait. Is that even? Well, okay, yeah, I suppose, yep. 10 factorial for these. Yep. Oh, the outermost won't line up with any other tiles. Hmm. But that still means that an inner one could have multiple. This lets me easily find the top one though, right? This should make it really easy, because then I can just search a tile that has no matches here and no matches here, and then search for other tiles that don't have a match once, but do have a match here. And I can do that to build the border. And I figure once I have the border, then well, then I can just start in the edge again, because I know two values here. And while it might still be the case that something has the outer value twice, yep. Counting. Wait a second. Yeah, that was what I just thought. I can just do that. But I'm fairly certain that I'm gonna need to properly map it out for the second, right? So it would be better to do it properly. Yes. We don't like the cheese, man. Also, someone wrote me on Discord. Let's see who it was. I have been highlit once. Okay, so so we'll keep this open because might be useful for some action later on. I mean, let's see. Technically, the solution for this can be, first off, 4 different rotations, and then technically for each of these rotations 4 different flips. So there are 16 possible solutions, but that also means that for me it should not matter where I start. So once I get a tile that can be, like, once I get a tile to put in a corner, I can just put that at 0, 0 in my matrix. And I don't need any more. So I do think we want to write to get neighbors for a tile, and that should just return I apparently did it again. I have no idea what I did, but I did it again. So that gets us the neighbors. Now building the database of all borders. I could just call get border for every tile, and once I have something, like once I hit a border the second time, once I get that twice, then we drop it in the neighbor DB. But the thing is, when I'm building that, I don't really, like, I'm already returning all that apply. So then I probably won't need this function anymore. Like, am I making sense? Well, no, actually, it might still do well. Additionally to this, I might also need a rotate tile function. So this always returns it clockwise, which I supposedly would want. We'll also need lip tile. And I would be very surprised if that is not a thing. How do I give it the axis? Do I just axis equals y? Or what exactly do you expect here? Steff, help! Oh, so it's just 0 or something. I have no idea why I would need that. It might be useful. I can just call this. Yes. Chill. So, what the fuck is this? Excuse me, what? Oh, and -1 returns it backwards, suppose. Just simple Python. I'm kinda, not gonna lie, I'm a bit stuck on what exactly to do. It's already 10:30. Holy shit. So what we need to do for the get neighbors thingy is I mean, we could do corner tiles, which is a dict, I suppose. Border tiles and inner tiles. And then we just iterate through all the tiles we already have for tile and tiles. Okay, good. I didn't fuck up the access for a dictionary once. Poggers. So. Interesting. Can't access this, but it can access the neighbor's one. So essentially what I want to do here is, if the sum of the time we find the exact border in the border for every other tile is larger than 1, then decrease the outer border count. So how would we do that? I suppose if sum for, and then we have to map this with how do we call it? Get border? Borders. In tiles. Like I already know that this will not work. But yeah, maybe you know how to do that. Then we do essentially here. Well, it shouldn't be in, right? I think you know everything. So I'll write it out. Like again, we. Essentially, how to write this without it looking hella bad. And after that, we do if. Yeah, of course it's not too bad, but we want the fans. We want the fans saying no. So if outer border is larger than 2, I want it to print. I wanted to print me the ID because something is wrong. It should never do that. Else, if outer border is exactly 2, then we can designate it as a corner tile, so corner tiles ID is tile. Else if outer border is 1, then it's a border tile. Or I suppose this name is not very well chosen. It should be outer tile, I suppose. Then we add it to the outer tiles. And else, which is no matches. 4 matches. Get border returns me this object here with 4 arrays. Oh no! I'm getting the belt. No. Else add it to the inner tiles. I see no shit. I am about to sleep. Well, Saturn, good news for you. If the last stream is anything to go by, then we're gonna be here until tomorrow. Zedwood pigs. Oh, it goes by borders by default. So I need to do values. So what you mean to tell me is I need to do this, right? Because the values thing is because yo, bro, I'm sorry. At the beginning I thought it was a cool idea if I named it top, bottom and so on, and would just, you know, exit by name to make the code super readable. That was kinda the plan here. At the beginning at least. Okay, so now with it being a list, this is not an issue anymore. That aren't all the border. Yeah. Yeah. Now we need to do the inverted ones, huh? Oh, Saturn, you did not mean this one. Okay. Because I was like, what the fuck do you mean? Yeah, dude, I just googled labor of love. I don't know, man. I'll never know with you, eh? So, the real question here is now, how did we do that? Steph check, is that correct? Well, it should be. Anyway. Also, no, I'm not doing Labor of Love. Mainly because the song doesn't really do anything for me. Might be a good song, but it's not something I think I can map well. So I'm not mapping it. Oh. Okay. So, like this question? Yep. Okay. Good. Thank you. String indices must be integers. Where? Line 12? Huh? Line 38? You missed Daru. Yeah, I mean the plan was to stream Steins Gate after Advent of Code stuff. But Advent of Code, as you might have noticed, is not going as quickly. So Daru has to suffer. If bordering get borders T. T is ID, not tile. Oh! No, I have to change it up here as well. I have to change it in both, right? Wait a second. Border wants... Oh, border wants a tile. Okay, yeah. Wait, but why? Huh? Huh? Yeah, here, yeah. But I only added that. The issue was here before. I mean, this doesn't change anything, right? It shouldn't. Yeah. Oh, no, so I have to use... You iterate over keys by default! Yo! I don't. Lies. 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 Come on, but that is stupid though. That is just stupid, dude. For real. That's just stupid though. It isn't. Well, you're only saying that because I said the opposite. So the thing is that this bad boy is apparently not able to directly compare if it's the same. So do I have to iterate through both? That would be kinda annoying. I mean, here it says use A any or A all, but I mean, if I do this, it's not gonna respect the order, right? Oh well, it's... Bro! Can make them tuples. Is that... I think I saw that in a code snippet you sent, right? It's just this, yeah. Chill, I am aware that I need to close them. Oh, that... At least something is happening. Amazing! Epic gaming! This doesn't compile, right? Oh, it does. Yep, okay, good. Because that I was kinda annoying me. So, this does not work because... I wonder why. So it always goes into this, which also means it checks this and it checks this. But it also checks this, so... This is being called 4 times. Oh! Because obviously... we only want the first 4 then. Because now it's iterating through all 8. Well, wait. But now it only finds 1 corner tile, right? So the issue is that technically, since we mirror everything anyway, it should be fine to check only the first 4. Since the second 4 are just the first mirrored. But... oh, of course. Wait, no, not of course. I can do that as well, yes. I can do that as well. I kinda checked that with greater 1, but since I do need to check the 8, oops. If t equals tile continue, which then means I make this greater than 1. Let's see if that changed anything. Again. Because... oh god. There has to be a numpy dot equals, right? Okay, good. Numpy all, okay. But still, it only gives me a single corner tile, which... because I don't actually want to read all these, let's just print the length instead. Because we can figure there have... well, there has to be 4 corner tiles, right? So the question is why? I suppose let's call this neighbors instead. Let's have it start at 0 and increment it whenever. I count A, B and B, A as separate matches. Yes, I think I do. Okay, so we have 1 corner tile and 20 set tonalized print. God damn it, dude. You're going to raid before sleep. Well, have fun, my friend, have fun. It's not a phase! Now that my borders are tuples, I could turn it into a set. You mean set as in... this returns a set, or... But then I can't get the first 4 from this. Then all you need is O. No. But for a set I can't do this, right? Or can I? Can I slice a set? I can't, right? Yeah. So how would I then go about getting the first? Ah. Ah. Would I then need to... Oh, also I think I know what my mistake here is. So sorry, Steph, I I'm pretty sure that what you have is smarter than what I am going to do. But I don't really understand what yours does, so I'll... Or I don't understand how it checks this, so I won't use it for now. I think my approach on this is wrong. Essentially, if matches is 0, I want to or a face, let's call it. So essentially, if for a border you have 0 matches, so this never gets through, then we increase the amount of border faces by 1. Since we're only doing it for the first 4, we don't have to worry about having to halve the result, right? So now if... Because I also know why mine wasn't working before. The issue is, since technically an inner tile can have multiple matches, for every match it would reduce this, right? Which I could have also just fixed by breaking here, I think. Wait, no, actually, no, I probably wouldn't have. Let's see if this actually does what I hope it does. Well, that is an issue. With a 12 by 12, how many is that? That's 24 plus 10 plus 10. So we should be getting 44 total, translating to 4 and 40. We're far from that in both sides. What confuses me is how we actually get more than before. Because this should have restricted it a bit harder, right? Or it should have made it more accurate, I think. So... if you have 2 things with 0 matches, then you're a corner tile. That, well, I would hope that to be correct. It apparently isn't, but... Also for this... Don't check under your mattress. Alright, buddy. I will not. So I doubt that this is the issue, because that just makes 0 sense here. It's not. Okay, good. I'll still do this, because presumably that makes a bit more sense. If border is in get borders for T, increment the matches. So I guess it's less in there than before. Hmm. That's a lot of stuff that doesn't match anything. That's way too much. So something with this does not work, right? Program goes brrr. Hmm. Yeah, it checks when the border we're currently testing is in any of the other ones, right? Oh, it's printing so many. Obviously, because if it's not in one, it doesn't mean anything. Yeah, so that's kind of whatever. This one was useless. The question is, it still apparently finds too many here, or something. Or it doesn't find enough here, rather. Because we obviously got way too many of these. Also, why is this so low then? That basically means we have... I mean, if I essentially take all of these and put them here, then we're missing one outer tile or one corner tile. But apart from that, we have all of them here, assuming that all of these have at least one border face. But first question is, which one is the ones missing? Like, which one is missing, and why are there so many false corner tiles? Let's print the border face. Let's... oh, we already removed that. That is very good. 0 0 0 1 1 1 1 2 2 2 0 0 0 0 0 0 1 1 1 1 0 0. Okay. So that doesn't look too bad, but... oh. Oh, because it starts at 0. Oh, yeah. Wow, it's correct! Oh, what a surprise! How long did you notice, by the way? A bit, yeah. Figured. Anyway, so that gets us all the outer tiles, at least. Because I obviously don't know what the next task is, I'll just... well, let's call it solve. I'll just solve the puzzle for now. Multiply. Wait, I just wanna multiply the IDs, right? So, corner tiles dot keys wait a sec. Where's the product? We want the NumPy product, right? I'm not sure. Okay, wait. So is that actually how you do it? I wonder. Generate her object first. Gen expression, and it is definitely not how you do it. You say multiply, but multiply. There is multiply here, but that only takes two things, right? np.product, okay. math.product, okay. Oh, that needs an array, so we probably want math. I need to import math then. Yay! Please don't call it strange, I worked very hard for this. Yes, I could have just done a for loop. Yes, that is very much true. That would have been boring. Okay, nice. Yay! NumPy would autoconvert. Well, NumPy was scary. That is the right answer! You're one goal step closer. Continue to part 2. This is where it gets bad, right? Now you're ready to check the image for sea monsters. The borders of each tile are not part of the actual image. Start by removing them. The tiles become... Remove the gaps to form the actual image. Now you're ready to search for sea monsters, because your image is monochrome. The sea monster will look like this. When looking for this pattern in the image, the spaces can be anything. Only the pound signs need to match. Also, you might need to rotate or flip your image before it's oriented correctly to find sea monsters. In the above image, after flipping and rotating it to the appropriate orientation, there are 2 sea monsters. Amazing! Determine how rough the waters are in the sea monster's habitat by counting the numbers of pound signs that are not part of a sea monster. I mean, first off, let's copy this. Secondly, let's clean this code up a bit for its purpose. It's not much, but it's something. We also won't need you. So now we need to do it anyway. Yeah, I just wanted to at least get 1 star. Uh, 2.24. Did we really start? Did we start at 9? Oh yeah, might be. Might have been. Also, I got like 5 messages already again. So this, by the way, is the good solution. Yeah, I mean these set operators are mean, or rather these logical thingies are kinda mean. So you essentially just, which is what you. This is, by the way, the same thing that you wanted me to do. Also, yo, you don't send me stuff where you're using more functions that you didn't specify. This is not that short, because somewhere you have share borders also defined, which you did not send here. You just want to show off and look cool. That's how it is. Another case cracked. Oh. See, I knew it. I knew it, you filthy cheater. Also, self.borders. You're still doing it, bro. This is a bit more complicated. Yeah. This makes me kinda depressed. Not gonna lie. Well, at least we don't need this one anymore. So because the first part is we need to build the damn thing now, right? You have all the neighbors of all the image, all nicely Yep, we do not. We do not. We can't share more. Yeah, okay, yeah, that's the border spot. Yeah, if you give me more, then you'd give me how to build the thing, and that's not what we want here. So, how I figured I could be doing this now is, for the first, we can just pick a random outer tile. Well, let's get out the frosty paint. Is there a way to erase everything? That's the question. Whatever. So, I think I was at 20, right? So now we have... the corner pieces, the top pieces, and the inner pieces. So we have this 4 times, we have this 40 times, and we have this, the remaining, what is it, 144, so this is 100. Wait a second, this is 100? That means the middle part is 10 by 10, and I have no idea what I'm gonna do with that amazing information. Alright, so now that we have established this, how would I go about this? Like, essentially this is just a normal puzzle. So, in real life, how do I solve a puzzle? Well, we can't make our program do it like a human, of course, because obviously in real life I just pick corner 1, corner 2, corner 3, corner 4, and then just build on all of them until we finish. Or in other strategies, you'd finish the border first, and then work your way towards the middle, right? So we still will do the border first, obviously. So what we probably do is we pick a random cornerstone, pick from said cornerstone a random direction, which it has a neighbor, then just add 10 times a regular border piece. Then add a different cornerstone, which has to have a a border face on the opposite side. Like essentially, it has to have a border face on the top side and on the side we're going in. It has to be the case for that. So since here we're going right, this has to have a right border face. That has to be, and it has to have a top border face because that was the case for every other one here. After we hit that, we go down 10 times. Then find the next one, which has a border here and here. Then we go to this side 10 times. Until we find you with a border here and here. Then we go up 10 times until we hit back the start. Once that is done, we build the border. And then we again start in the same edge, but this time instead of searching stuff that doesn't have any borders, we search stuff that has this border and this border in that constellation. And then we just build the same way as before, so we just go this again, right? And then we repeat this ad infinity. No, we repeat this, what? Nine more times. So that's how we would go about this programmatically, I think. Which is also really nice because the first one I have to do manually, and the second to finish I can iterate over. You say that is one way, so I would assume that there's a better one. I mean, obviously another way would be we start again here with corner piece, work ourselves down 10 times, hit this corner piece, then instead of going the regular border like before, we go top to bottom while keeping in mind the You don't think your solution is any better? So those are two ways. The question is, which one is better? I think this is probably better to implement. Then again, I'm not sure. This might be easier because I only have to check effectively one side at all times. For this one I need to change the sides I'm checking. And also this lends itself better to iteration, I think. So we would just do it. Oh god, I hate drawing with mouse. So the question is, how do we do that? Alright, so I mean, building the first line of 12 remains the correct play. Let's write this like this. So first off, we're gonna need Don't want the numpy array here. We can do a numpy array. So tile layout is a numpy array. With a size of 12 by 12 and integers, and I still need to do this into a tuple. So this is where the fun happens. Tile layout 0, 0. Is just the first of the corner tiles. That's fine, right? Let's also extract this method. Oh, this is an issue. So we would need to add the ID here, right? Yeah, but that's okay. So now we make this into a get matches call with ID border. I mean, brother. I'm not sure. Is that even better to read? I have no idea. But anyway, now that we have the get matches here, we can Mm. Am I using tile outside of this? I am not. That is good. Can I always do this? I cannot. Okay. Mhm. Yikes. Alright, man, you know what? Like, I kinda... that needs to do as well. I kinda thought about what to do, but I don't think I'll get much more done today. So I'm just gonna call it for now. Probably Advent of Code won't be finished by the 25th. Only exception if the stuff coming tomorrow and on Christmas is super easy, which I don't think. But yeah, thanks man, and yeah, today was super easy. Well, I'm stuck on this bullshit, so because the bigger issue is this is just some tedious stuff to work out, right? But finding the sea monster is probably even more. So yeah, that was easy. Okay, is that just a pattern match or something? Anyway, I'll try to stream tomorrow as well, hopefully a bit sooner. Cornwall. And yeah, I'd say if I'm stuck for like an hour, you can backseat me really hard, because I don't really want to be stuck on this one when the rest is, let's call it, a bit more fun. But anyway, yeah, I think what I have here, like in theory, should be all I need, because once I build the tile layout, I can just build the entire image afterwards. That should not be hard. Stripping the border is also not an issue, I think. And yeah, if convolve. Wait, let me find something. Do we get do we get copyright strike for this? If it happens, it happens, right?
Oi, we ain't done yet. This mustn't register on an emotional level. First, discombobulate. Dazed, discombobulate. Distract target. Discombobulate. Block blind jab. Discombobulate. He'll attempt wild haymaker. Discombobulate. In summary, discombobulate.
Well, we really did discombobulate. More discombobulating, please. Tomorrow. But yeah, I'll try to get tomorrow in. Hopefully, I still need to do some writing, but if let's say if I don't procrastinate it until the evening, like I did today, then I'm gonna be done with that by the evening. So that should work out. And yeah, hopefully tomorrow we get some pace back. Let's call it that. Anyway, if, as you said, the newer ones are easier again, then hopefully my brain can do some of those. And yeah, if this is gonna be really bothersome, like I don't think it's too hard. Like before I implement it, I don't know if what I have here is going to work, right? But assuming it does, this is just gonna be really annoying to do. Because checking this, then I probably need to check for every single tile if it's flipped or not. Or I need to do the flip check here, and here, and here, and for each one, and then I have to flip it in the dictionary. Yeah, that's just gonna be tedious as fuck, right? So yeah, let's see how that's gonna work out. Like it doesn't seem to be hard. It just seems really annoying. That's why you made a class, yeah. Yeah. Would have been smart in hindsight, maybe. Maybe. But when have I ever been smart, right? Never. And yeah, so with that, I'll leave you to your bed or whatever you're gonna do now. And discombobulate. Bye.